Nandita, we are live. We can give a couple of minutes people to join. So once after that, we can start.
Sure, Srikesh.
Yes, Nandita, I think we can start.
Okay. Hello and good evening, everybody. Welcome to the 49th edition of Geeknight Coimbatore. Geeknight is a monthly event to promote sharing of technical knowledge and increase collaboration between geeks. It is organized and sponsored by ThoughtWorks. Geek Night is an open forum for both presenters and participants. If you want to be a speaker at Geek Night, please use the link. We'll provide you with a link to register as a speaker. First up in today's edition, we have Gautam Nivas from ThoughtWorks to present on test-driven development with VueJS. On to you, Gautam.
Yeah, thank you, Nandita. Just give me a second. Cool. Okay, I'm Gautam. I'm an application developer at ThoughtWorks. I've been ThoughtWorks for around 2 years, 2.5 years from for now. Um, so I've been also practicing TDD for a while, um, um, uh, a good amount of time. I've been always wondering about TDD, about front end, right? So why do we need TDD? Do we need tested front end and everything? So I've been practicing front end TDD also for quite a bit of time. So I was thinking this area is fairly a little bit less explored, and we don't have enough market documents uh, or tutorials or guides for you to actually go and easily explore. Everything has to be explored ourselves. So in that note, I was trying to give an introduction to people who are like me, who want to know how front-end TDD, front-end unit test can work. So that is the intention of this speech. Let me just start with something as a note for you. Cool. I am hoping you can see my screen. Okay. So the topic is again TDD with VueJS. Why VueJS? There is no particular reason. It is just one of the.
Gautam, are you sharing the screen?
Yes, I'm sharing the screen. Are you not able to see?
No, I'm not able to see.
Just a second. Now are you able to see my screen?
Yes, Gautam, we can.
Yeah. Sorry for that. Yeah. So TDD with Vue.js, right? So why do we need unit tests for the front end is a very good question. Like I've been always asking this question. Do we really need tests for front end? The answer will be yes, right? I will tell you the reasons why we can say that we need a test for front end. Uh, um, we all have heard about test pyramid, right? So we have low costlier tests, which is at the bottom, and we will have acceptance test at the top. The reason is writing an acceptance test is very costly. Maintaining it is very costly because UI changes or small particular changes will break the acceptance test, and also taking time to write the test is also costly. So we tend to write more unit tests at the back end, right? So it is very similar for front end as well. The reason why it needs to be automated, and why we need more tests, is because we cannot afford to do manually hereby, because there are many devices now. We have mobile, we have web, we have iOS, we have Android. Can we go and test for all the devices? Can we go and test for all the browsers available in the market manually? No, we cannot do it manually. So when we write acceptance tests, what is happening? There are more acceptance tests, and there is more breakages, more maintenance cost, and everything. So why do the same approach for as we followed in the back end earlier, like more unit tests? So if you want to write more unit tests at the front end, then we have to write very less. We can afford to write less acceptance tests in the front end. So maintenance also becomes an easier affair. So that is why it is forcing us to write more unit tests for the front end. Okay, and there can be many points similar to backend. So let's move to the next question. So why TDD based approach? So we say we can write more unit tests and everything, that is agreeable, because it is a less maintainable test. But why TDD approach, right? If people watching knows TDD, they might see TDD as a difficult approach, because TDD always follows red build and then make it green, right? Code and then make it green. So people are not used to write to know the test before writing the code, and that is the main fact of TDD, right? So why we have to know what our code is going to do before we write a test. That is the main fact of TDD. So if you say I cannot write a test because I don't know how the code is going to come out, then that is the actual problem. The developer has to have think twice before knowing this method is going to do this exactly. This is what I want this method to do. So that is what TDD is forcing us to do. And this enforcer, what will turn out is good structured code. So it will give us a good design of the code, because we will think about the test, we will think about the method signature and everything. We think about exactly what the method has to do based on the requirement, right? We will not write unwanted codes. So we will prevent writing unwanted codes when we write TDD. So these are some of the examples for why we have TDD, and why it will help in front end, right? So in front end also, designing a good component structure. Let's say for VueJS or React, they have components, and writing good component structure or writing a good design is very important to maintain in the future, because these frameworks have um, core concepts, how they render data, how they have a hierarchy and everything, right? So in order for us to follow the proper language basics, so that we write a better code for the future, then TDD is a go-to approach, right? And also we don't have very good documentation of the front end. So TDD will help us document every components, methods, or features, right? So, so this TDD approach, so this documentation approach is a true approach, right? So if you create a document, let's say I can create a document in text in a text file, you can say, or even in the JS file. But what it happens is over the period of time, it tends to expire, or tends to get outdated, or you cannot trust a document. How many of us can actually trust a document, right? We cannot trust a code document easily, because we don't know how many years back this has been committed. If you see the code would have been committed like 2 days back, but the document would have been committed like 1 year back or 1.5 years back in the legacy code base. So then how can you even trust? Because the one who wrote the document is different and the one who wrote the code is different. The only one way is to find the code, right? The code does not lie. Also the unit test, because the unit test executes the code and tells us whether it lies or not, right? So that if you write proper tests with the proper uh, statements or expectations, then the actual expectation will tell you that this is what this method exactly does, and it does not lie. You can trust on the test, and it is also easy for maintaining in the future. So these are the things why we need a TDD and we need tests for front end, right? Um, uh, and yes, we are online, so it's not possible for people to ask questions. I agree, but if you have questions, please put it in the YouTube chat. Like, probably the volunteers will help me get the questions and answer it. Okay. Cool. Let's move to the next part. So what we are going to do in order to do this, are we going to theoretically learn? No, we are not going to theoretically learn. This is the utmost theory that we get for today. We will move to the codes very fast. But I'll just summarize what we are going to do. We'll create a basic. We'll try to create a basic to-do app, um, test-driven with VueJS. This is our motto for today. I know we cannot complete a to-do app TDD within today, but we can do it as far as we go. We shall not complete the app, but we will learn the basic crux of it, and then at the end, from where we are, like probably like the people who are seeing this can actually write their own to-do app or continue the app that where we are left. I will also try to provide a GitHub link to my code base if it's possible. So let's start then. Um, I will use VS Code GitHub. Okay. I like to do it in VS Code, and people who are doing VueJS can use any editors for this. So I'm going to use basic Vue command line app to create a basic app. So I have Vue CLI in my local already. If you can see, so I have a Vue CLI installed. It lets me create a basic template app, which will give me a good starter. Um, so I will use that to create our to-do app for today. Let me click. So the command is view create to do. So it takes a little time. So it asks many questions, right? So uh, let me just finish this. So I will always want to select manually the features. I will let you know why the reason. So I don't want a default app, so I will select for manually select manual features. Good. So it tells me, it gives me options, gives me router options, gives me TypeScript. Yes, you can write in TypeScript if you want. I prefer to write in JavaScript, with JavaScript without TypeScript, and I can add a router. I will show you what a router is. And then I will add unit testing and end-to-end testing just for reference. This is why I selected the manual feature, right? I wanted unit testing template already present inside the template app that we are going to create. And let me go to the next step. It asks me whether you need 50 email for router. I will say yes. And I've selected standard config for now. So this is ESLint config, right? So I will select a standard config. Lint on save is a good option. So I will use just for the testing framework. So this is very important. There are two frameworks which are coming as a default in the Vue CLI service. and one of them is Mocha and Chai, and one of them is Jest. I am used to Jest. I have no, I don't compare against both, but since I have used Jest, I will use Jest here as well. Um, so, so there are two things again. Like if you want end-to-end testing, it will have Cypress and Nightwatch. I will select for Cypress. And where does the ESLint configuration has to go? I will say dedicated config files will be good. I will not save this for the future. Cool. Cool. This might take a while as it says. Meanwhile, I will tell you what this is going to create. This will create a sample view app, which will have placeholder templates for end-to-end testing, unit testing just as a framework, and we'll have routers. Routers is nothing but simply Vue provides a routing mechanism which can load different views uh, on clicking buttons, right? So like you're on the home page, if you want to go to the about page, it will give you the routing mechanism to do that. Yeah, while it takes a while, I wanted to explain something. So we are not going to, our main target is not to learn Vue or to learn VueJS principles. We are going to learn a TDD approach for VueJS. Okay, so I will primarily concentrate more on how we can write the test in VueJS rather than how VueJS is designed and everything. But I will not shy away to explain some of the VueJS things or components that we are going to create. I will explain some of them, but will not completely teach Vue.js here, uh, but you can expect both TDD and Vue.js in this session. So if we add Cypress, it takes time because Cypress loads itself, downloads itself from the internet, and that is an automation test framework. It has a web driver which can run UA-based automation test, but we are not going to look at that. Yeah. So it is complete. What it says is the project. So I have, okay, what I click this to that. Let me go into that. Let me open that here as well in the US code editor. Okay, my code has some problems. Let me reopen the code. It's not asking for. Let me try to open recent and then switch back. Give me a second. Let me try to add this workspace folder. Okay, I opened one of the existing folders because the VS code is not allowing me to add a new folder. Let me try from here to add that. Just give me a second. I will just close VS code completely. Okay. Okay, this is the app that we created recently. So we'll use that. Okay, if you look at the project structure and folders, there is a source which has everything, and there is a unit test and end-to-end folder which we asked the Vue service to create. Okay, and I will create a new terminal. Okay, so this is our start. Let's see what is there in the main.js. So if people knew VueJS already, like this is the main. From here, the app is rendered. It loads app.vue. So this is the app.vue which is getting rendered by the VueJS. So let us just check if it works. Okay. So there's a command called npm run serve, which is created by this template, which we will use to see if it works. Okay. So we can see my screen. So this is the to-do app that is created by this Vue app. So what we can do is, so it works. We can close this and we can start writing our test, right? So what is our app's requirement? Um, so this is the unit test example that we can see. So we are going to write a unit test as this for our application. So in TDD, we only start with tests, right? So for that, we need to know what we actually want, right? So I'll just show you text folder so that I can explain what I'm thinking in my mind. So we need a to-do app. A to-do app will have a list of items, right? Item 1 and item 2. It can probably have a delete button like this, or whatever, like it can have underline or strike through or whatever that you want to have. And you should be able to add the to-do and add box or something. But let's just concentrate on the list first, right? So there should be a list which will display everything, and there should be each and every to-do component, right? So this component will have a button to close this or do some actions over it, but we can understand that there needs to be two components. First, there is app, and inside that there is to-do list, and inside that there is to do. And this is not the only design we can approach. There can be many designs, right? So this to-do list will have multiple to-dos. It's an array of multiple to-dos, and the list will be one, and the app will have the data, right? So the app might have another like add to do as a component, or search for to do, or deleted to do, or whatever. Right? But so this app will be the main component, and to-do list and to-do will be the component. Let's focus only on to-do list and to-do for now, for time being. So in TDD I usually follow a bottom-up approach. I write the smallest components first, and then we write the bigger components next. So what it helps is, because we know exactly what smaller components does is, right? So if I give you a calculator as an example, um, like write a unit test for calculate function. Can you, like, it does so many things and we do not know, right? So but if add is one of the functions of calculate, of the calculator, then it is easy to understand that there can be a method called add. It can have to signature and everything. So similarly, um, so I find to do as a component which will have only this item title for now. It can have multiple others, but I feel that this is the smallest component. So this is the bottom of approach, which I use for TDD. So let's create a test for that. Let's create a new file. So let's name the component as to do. So then the test will be to do vector.js. Okay, I will copy elements from here. Okay, and then we can start. Cool. So this is importing hello world. Let me change it to do. So I have imported to do, but this does not exist. We know that, right? So of course this will throw an error, but we will write a test thinking that this component exists. Okay. So I'm here testing to do.view, and I will say that it should display a to do item, to do item, to do title, or whatever. Yeah, cool. And so this component, right? So this view component, let's look at the view component, how it is. Just for an example, there are many components. Let's look at a component. So we'll remove the unwanted things out of the component. Then, okay, let's take home component and see what is there in the home component. Okay, it has a template, which is it's plain HTML, and it has a script where we can write Java scripts and everything. And we can also have something called style. Here we will have CSS components and everything. So this is how VueJS will group together every view file, and components are also similar. Okay? So the app view will also have similar things. It will have a template. It has a style here, but it does not have a script. So a template is a mandatory thing, but a script or a style is non-mandatory. So we can have it or not. It depends on that things. But the script can have export default method, which will say the name of the component, and it can export components, or it can have props, or it can have data. So I'll tell you about props and data. Props and data are simply data that can be used to be the components. But the difference between props and data is mostly like, if you want let's say to-do list app to have the data. Let's say app has the data, and to-do list can have props. Okay, and to-do can also have props. So this data can be a list of the user to-do data. Okay, so this can be fetched from API or anything. Right? For now, we won't have APIs, but this is what we can have. And this is called data because this data is originated in that component. There is no previously another component holding this data. So this is called a data. But when it gets passed to the lower component, props is the right way to actually pass. Okay, we can only pass the to-do list from the user data, So the props will have to-do list probably, and the to-do will have only the to-do because it won't have the list, right? So it does not need the list. Only need the so now we can see, right? So if we write unit test, we need to come across these things. We will not think about app, but we will at least think about this component, that what it needs to render. So it needs at least a props to render, and I don't think it has to go and fetch via API. It will be given the data, so I'm selecting props as the tools to as the mechanism to send the data. So in our test, what we can do is we are already mounting shallow mounting to do app in props data. We can, so here the test example as actually a message, but we will have an object. Okay, we will have a to do object. We can have title as get up early in the morning or something as my to do. Okay, so if we shallow mount this, what will happen is this component will be mounted by use VueJS, and uh, the wrapper will have the actual data of what it has been mounted, and we can perform test over the wrapper. So if I load this to-do data to this wrapper, which means to do this to the to-do component, then the text of the wrapper should match my to-do.title, right? So this is the lowest of my components, and it has to display my to-do item. So yes, I have written the test. Let's see what is passed. I can use yarn npm run test to actually run the test. Sorry, it's npm run test unit. I think you can refer how to run this in the package. It has multiple methods. So the npm run serve also comes from here. So everything is performed by Vue CLI service, which we already installed previously. So this is the service that created this app, and it provides tool to serve this app and build this app and also run unit tests on this app. Um, yes. So this test has failed now. Right? That's what we are expecting. We expect this test to fail, and it fails because there's no to-do component. Yes, we haven't created a to-do component. That's why it fails. Let's create a component inside the components folder. We'll call it to-do.py. Right. So we are importing to-do component, and let's say what the error is now. Now we have to-do component. Cool. It says the match is unmatching, right? So I have loaded the component, but yeah, so the text actually does not match. There is some problem, which is our expectation because we haven't wrote anything inside the to component. So it is correct to actually fail, right? So let's write the to do component. So let's write from template. Okay. This is the template which will have the actual thing, right? But in order to have the props, like in order for me to have props, what I can do is I should write script. I can copy this from okay. So I will copy this structure from here just for time's sake. Okay, there is no level component, and the name of this is to do, and there is no components here. I'm not trying to load any other components. This template should have a development. Probably that's why it's complaining. What else is the problem? Let's continue. Okay, probably there are spaces which are required. Fix this. Okay. I'm not sure. Okay, now we could comment. Cool, but let's look at this later. Once we complete, we can look for this later. This recording. I'm not sure about this. Let's give ID for our bit tag. Just like that. Okay, cool. Let me continue. So let's see how it goes. And I have added a name, but that's not it, right? So I need props. Props is an array. So we can declare as many props as we want here. And to do is our props. So we are getting to do object from here, to do as a props here, and we are wanting to put it in SQL. Okay. So we want this template to display our title. That is our motto, right? So in order to access this props, we need something called a vbind. Vbind will bind your data here. But for simple things like this, there is also another possibility. Usually we use vbind, but if you use curly braces directly, we can actually directly access this to do props like this. Okay. So this should actually pass, but let's see. I'm not sure about whether the problem is from ID or not connecting. Okay. Okay, the test has passed. Okay. Cool. So there is an ID problem. I think that's what is causing me this problem. Okay. Previously we had a failing test and we made it pass because there is a title which is being entered. Let me remove this title to, or let me have a different text or something. It fails, right? So it says the to do title is test, but it's supposed to be gettable in the morning. So this is the valid test. So whenever there is a problem with the UI, this should say that this test should fail. That is the important point of writing a unit test. Okay, cool. I'll have to fix this ID problem, but let's see. Probably I will run yarn link or something on this file. Fix the file. That's okay. Okay, cool. Let's continue. Like our test is passing. Okay, so we were talking about the components, right? So if you go to Sublime, so we can see that. So we have created one component. So this is done. It is showing the title, and we need to create a to-do list component which will actually show the to-dos. Not to do that, we will create another component, but for another component, we will write another test, right? So we will write to-do dot to-do list. Let's say this is to-do list dot spec dot js. So I've named the other component as to-do list, and we have to write a test. Okay, cool. So so for this to-do list at view, what is the expectation? The expectation is it will have a props and will have a list of to-dos, right? List of to-do objects, and this should be rendering the to-do components. Okay. So in order for this to render to do components, we need to do certain stuff here in that component. So that is the logic. So the logic of to-do list is nothing. It is not displaying the to-do titles. What it's doing is it's just only rendering the to-do components, which is the child components. So we should only test whether the child components are rendered, and we should not test whether the child components is rendered properly. Then that is not a shallow test. We should write only unit test for that particular component, and we should not write unit test which will cover the logic of the child components. That is an anti-pattern in unit testing. Okay? So that only that particular unit should be tested, and other units should be abstracted out of the test. Okay, so let's continue. So display multiple to-do components. So it will display to-do components, and I will have a to-do list, and this will be an array. First, let me write just. Okay, so if we have multiple arrays, let me write something else here. Email. Okay, so if I have two to-do lists, what this to-do list component should do is it should render all the components. So I have to verify whether that's rendered. So let me import to-do list also, which is not at present, right? Cool. And how can we test this? So there is a way in VueJS where we can get the components, get component inside the, and we can pass to it. Okay. But there are multiple components here. So what we can do is we can do get all components. First, instead of so let's just get to do components. Okay, wrapper.get all components. So what it will do is it will return me all the components that are present inside if it is present, right? And if on each and every component, what we can do is give me a second. Yeah, this method is not a get all components, it is find all components. So wrapper will find all components, and what this can do is this will return object called wrapper array. So in order to get wrappers, so we were testing on wrappers only, right? So in order to get wrapper from wrapper array, what we should do is we should write wrappers, and it will return the wrappers. So this is an array. Now this is an array, so we can get we can do this on this. Okay. So now what we can do to test is to do components 0. We can either do text or we can do validate it anyhow. But uh, so now the question is whether I can validate the text, right? So I know the text. I know that this is the text, but can I validate that? We should not validate that. We can only validate whether the child components is loaded with this props, because that is the only logic that this parent component is present. So I will just test that. I hope you understand why we are not testing the text, because that is not our job. That is the child component's job. We only check if it's loaded with props dot to do. The child component has a to-do component, the props, and it should have a to-do object which is like this to-do list of 0. Cool. We can do the same for the second component. So probably this should work. So let's run the test. Okay, it runs well, and it says that there is no component. Let's create component then. Let's name it publish. Cool. We have to do list everywhere. Here there is no error. Okay, nice. And this is the next question. Like, so what all these components will have? This component will have a script again, and will have props, right? But this will not have to do. This will have to do list. So this is one of the concept this is having, and so what it has to do is it has to render as much as to do it has in this div. So what I will do is I can create an another list. Right inside that, so this list element, I'll create again a list element for each and every to do. For each and every to do, I want iteration, right? So what I can do is I can iterate and create a to do component. So in order to load a to do component here, what I have to do is I have to export the to do component. What I can do is import to do from to do. So I don't know what this error is, but let's continue. I'm hoping that this is an ID error. And there is a to-do list, right? So from here, there are components. There is something called components here, which we can do to export. So we'll create the components, and we can export to do. And we can export as many components as we want if you want to use. So there is no bracket. Cool. Once you export the component, what it helps us is it will help us use it inside the template. So we are creating a to-do component here so that we can export from here. You can import from here and exporting as a component, and this template is able to use that component here inside the VueJS. Okay, cool. Let me do something. So for using this variable, I need a v for. V for is for iterating something. So v for I will have to do I'm thinking I'm losing time here. Okay. Okay, so what it will do is it will just iterate through to-do list. This props, and it will create list for every things. But that is not enough, right? So I want the value to be, the component to be rendered. Not for the component to be rendered inside the list. You can render the component to do, right? But this component has a props, which we have to send it to this file. So we will use again vbind, which I previously spoke about. So I will just point them to you. So what this will do is this will bind to do the to do value here to the components to do props. So that's why we use vbind. So what this will do is this will iterate through the to do list and will create the components. Let me run the test again. What happens? Okay. Okay, that's an expectation mismatch now. So what it says is, um, so receive has type value. Received value must be a string. So we are expecting string here, but it's not it. Yeah. We should write to be to match objects in just. So I'll just run that. Cool, now it has passed. So previously it failed because to match is not the right one to compare the objects. It wants string. Right now we are passing objects and it works. Okay. So what we have done is we have created two components. One is to-do list and one is to-do. And what it is doing is it to-do list will render all the to-do. Now we need the critical part, right? We need the app part. This app part will have the data. So let's use the app here. For time being, we'll use the same thing. We will remove all the styles for now. And we'll also remove the routers and everything. And this is the app. So what we have to do is we have to render to-do item. So in order to render to-do list, so we need to import and export the component like in here. So we'll copy this from here, paste it in the app.vue. We'll copy the script. Okay. So now I have a script. So in the script, like I'm having to do, but here I will need to do list, and it's inside dot slash components slash to-do.view. Okay, and I will export the to-do list so that I can use this here. Okay, and as I told previously, this does not need props, right? It needs data because this will create the data. This is the originator of the data. So in order for data in VueJS, what we do is we created a method called data, which will return the data. So this is the syntax which we use to return the data. Just a second. What is it then? Okay, I have 5 minutes. Okay, so here I will return the to-do list. So let me call this to-do list. Okay, before that, we forgot to write the test, right? So let me write as I have created the component. Let me remove this data things and let me write the test first. So I will copy test from this. For time being, I will use the test that I already created so that we can complete some things today. I'll just come with the test from here. Cool. So what this test will do is should mount to-do list with to-do data, and I am passing the data to-do list the same data as to-do list object inside the return. And when I get the component to-do list I have to assert that there is a component inside app which is called to-do list. And the to-do components, I'm checking the props that to-do list is available. So the only logic of the app is to load to-do list, right? So I'm just checking if the app is loaded with the to-do list and with the right props. That is, this is the props. Okay, so this is the prop that has to prop to the to-do list. So that test is done. So if you go to the app view again, so I will create data here. I'm just copying the data for app view. So this will have data component. Inside that we will return as we spoke earlier. And here we'll have to do list. And I copied this from this project. Okay. So now it has data, right? It has the right data and it wants to load the components. I want to load to-do component here. So what can I do to load a component? So I've already exported, so I can simply do to-do list. What we will do is it will just load the component, but what we have to do is we have to pass the props. Like how we have passed the props here, we have to pass the props. I'll copy from here. Okay, but here it is not called to do, it is called as to do list. So what this should do, it should probably make the test pass. Okay, so it says the object is not present into the props in the test abstract.js. So it is checking if the component is right, but the component is loaded, but without any props is what it is saying. Let's go to the app view and then check what is the problem. So it has data and it has to-do list as data. And we are binding this to-do list to the to-do list correctly. What else is wrong? Let me check the expectation here. We are also loading the list correctly. Yeah, this is correct. The test is correct, but are we loading the app component? Yes, we are loading the app component and we are checking if the to-do list component is available. This is correct. I think the problem is with the app view only. Just verifying it against the previous project. Surprisingly, this is also correct. We copy the same thing and see what happens. The add process. What was the change? I think the import of to-do list was a problem. That was the only difference. It is // Okay, cool. But what we have done now is we have created a to-do list app component which will load to-do lists, which will and then load to-do. So this should already create a to-do list for us, which is a basic to-do list, which will only have the list of to-do items that we have. Cool. Let me try serve. It might give me ESLint errors. Okay, it expects vbind key. So I will tell you what this is. in the to-do list for any item or iteration, it wants key for all the items. So that every item or every component will have a unique key for itself. Let's create a key um, for this. Let us name it vbind key. So we use vbind because we are going to use something uh, okay. Now it has run successfully, right? So it is auto compiling whenever we make a change. So it is success now. Let us see what we see. So, yeah, this is the checklist that we are seeing. And yes, we have done so many things to make this work. But this is how TDD driven will force you to write a correct design. Um, and I will just show you my other project. Uh, just a second. Yeah, for the sake of understanding. So I additionally in addition to what I have created, I also try to create to-do component which has a completed task, right? So if it is completed, it has to be straight through. So in order to test those, I used to test here, which will test the CSS components. I created a CSS class called .completed, and when you click on the element, the class completed should be available in the element. So what this will create is a to-do list where you can click on a list and then it will become straight through. So I created similar things for this. Created another class style for CSS. I can show you this as well. Okay, so if you look at this app, so it has actions, right? So it can strike through or not strike through based on your clicks. You can do many things, right? You can add a delete, you can add a to do, but everything you can test. So I'll create this as a GitHub and send it as a meetup link. And also, like if you have any doubts on how to write unit tests for some conference, you can write me at gautaman@thoughtworks.com. Yeah, thank you. I will leave it to the organizers.
Hi, Nandita.
Yeah. Thank you for the instructional session, Gautam. Next, oops, uh, yeah. Next up, we have Navneet from Nunari Labs to talk about embedded machine learning. On to Navneet.
Yeah, hi Nandita. Hi Rikesh. Is my voice audible?
Yes, Navneet. I think,
Okay.
yeah.
Yeah, I'll share my screen. Give me a minute. Okay. So hope you should be able to see my screen, right?
Yeah, it's visible, Navneet.
Okay, fine. So yeah, I'll turn on my camera later. It's not required right now. Uh, yeah. So welcome and good evening. So today's topic is on embedded machine learning to run neural networks model. It's being quite popular these days on microcontrollers, right? That's pretty exciting. We have two things. One is microcontrollers, IoT stuffs, and on the other side we have AI and machine learning, neural network stuffs. So welcome again. A bit about me, what I do. Currently, I'm an ML engineer and principal AI instructor at Nunari Labs. And also, I lead two communities in Coimbatore. One is the TensorFlow user group Coimbatore and Coimbatore AI community. And also acting as faculty at few colleges in Coimbatore. I'm into development, research, and education. And being an TFAG organizer, I get access to work with Googlers on ML on mobile, and TF Micro Special Interest Group. So coming from an electronics background, I lately switched to software engineering, but I still wanted to stick with all the electronics chips and stuffs. So that's why I'm more into edge AI and edge ML stuffs. So a bit of context before getting into the actual technical thing. So for people who are completely new, just to give a context. So we have AI, ML, deep learning, and neural networks, and AI is anything that exhibits some sort of intelligence, and machine learning, learning from data, and deep learning, again learning from data, but the architecture is made up in the way it's kind of inspired from human brain. We have nodes, nodes, connections, and stuffs and all. We have different architectures for deep learning, like the traditional neural network, feed forward neural network, and convolution neural network for images, and recurrent neural for sequence processing, right? And if you see, there have been a lot of breakthroughs in uh, AI domain after the deep learning revolution actually kickstarted back in 2012. Okay, and deep learning, yeah, it's made a lot of progress, but there is one problem. Okay, so we will come to that. But before, if you see the data science life cycle, so the project life cycle, like any software engineering project, there is also an data science machine learning project life cycle. If you see how it goes, first thing is gather the business requirements, okay, and the next is data gathering, data collecting, and all, and we have a lot of stuffs on that. And next is modeling, hyperparameter tuning, testing, and a lot of stuff. Most of the people do till modeling, okay, and they stop there, okay. Only very few, maybe 5% of the machine learning projects, not even five, less than that, actually goes into the deployment, because deployment is another area to where we have a lot of things to take care of, okay, because we have people on the other side using the services, okay, and it has to do handle a lot of things, the incoming requests, the processing time, it has to be robust, it doesn't has to be failing. So we have a lot of tools and techniques for that. You know, on the cloud side, we have Kubernetes, Docker, and stuffs and all to handle load balancing, all sort of stuff. But when it comes to deep learning on edge deployment, okay, edge deployment is on right in the mobile phone, or else in a self-driving car, or else in a drone, or else take your smartwatch, or else a smart heart band, okay. So even those devices has some sort of deep learning model running on them, okay. But the problem with deep learning model is the actual thumb rule of deep learning is, if the size is more, okay, if the size is big, if the architecture size is big, and if you feed in more data, it performs better, okay. So that's where deep learning is kickstarting. If you see the latest GPT-3, it has about billions of millions of connections, and the size is always like size is about more than few GBs, the model size, okay. And if you see, for example, this particular image classification model, so AlexNet, that is where things started. And we have SqueezeNet, we have VGGNet from Oxford, we have ResNet from Microsoft, and InceptionNet and NASNet is kind of state of the art. So accuracy keeps increasing, but also if you see the operations, the floating point operation, like gigaflops, okay, so the number of calculations or the number of computation per second, it keeps growing like exponentially, like 100 million flops, 100 million flops per second. You see like how compute intensive all these tasks are, okay. And for server to handle all these things, we have certain things. We have multi-core processors, okay, we have GPUs, capable GPUs from NVIDIA and stuff and all. We also have custom hardware, TPU, okay. We can use them to train, and also we can use them to do inferencing, because when you're doing image processing or some video analytics, the frames per second is a count, right? So 20 fps or more than that would give a decent analysis. But all the, even our mobile phones, while you are doing onboard ML, it will not cross at least 5 fps, okay. And the servers, okay, we can handle, we can do AC room stuffs, and we can connect parallel, and we can do all these stuffs. But when it comes to edge, all these edge devices are very constrained device, okay. So we have everything is battery powered. It is not always connected to the internet. and the processing capability is very small. Okay, mostly it might be an kit like Raspberry Pi or NVIDIA Jetson Nano, and also we have Google Coral and Intel Movie Stick. So we have like two components, one to do the regular processing, another to do the all those matrix multiplication. Okay, but still it is a compute intensive task only, because you cannot operate these devices on battery. You need a solid backup battery power to run all these machines. And on the third side, if you see the modern, like now we have tinyml it's a working group. Okay, so we have all those models ported into the microcontroller format and being deployed. We will see that later. So now the technology is capable, we can run all these models on these tiny hardwares, right from Arduino, ARM and other SparkFun based modules. We can deploy them, but this is not possible 2 3 years ago. But right now a lot of progress have been happening in this domain. But if you see why want to do that, if you see the most intelligent device they projected it as, it will be on the edge. Okay, you can see 100 million servers and 3 billion phones and 12 billion IoT devices. But okay, again we will come to IoT later. And we also have 150 billion embedded devices. Okay, so uh, embedded device mean it can be a tiny sensor reading your heart rate, or else monitoring a plant, monitoring in agriculture, monitoring the vibrations of a machine, anything, right? We are trying to or current consumption. So anything you can connect to it. So if you see the applications, we have a lot of things, right from smart glasses. Again, you cannot have your even if you have wires in your Oculus Rift or HTC Vive, you will get irritated, right? You need it wireless. Okay, so when something goes completely wireless, we have a lot of constraints, especially if you see smart glasses, VR glasses, mobile phones, autonomous cars and drones and tiny robots. We have, it can do a lot of tasks: facial recognition, landmark detection, advanced driver assistance system, and a lot of stuff. But all these things, again, it has to take care of whole lot of things. But the main core thing is this part, the AI capability, and it runs on a some ARM chip. Okay, it might be Snapdragon or whatever it is, it might be some ARM chip. And if you see the application is endless. Okay, so right from connected device to smart cities to smart homes, IoT been of a trend for quite a long time. These days IoT been trend, AI been trend, but back then when I was in college, IoT was trend. I've been little experience in those things as well. So mostly we have tried to adapt the traditional technology like mobile based GSM networks and Ethernet to build IoT solutions. But lately we are switching over to other IoT only protocol like LoRaWAN and other stuff. But the thing is, we are trying to export all the data to internet. So we plug in a device to internet and we push or stream every data from the IoT device to the internet. Okay, but the IoT device has certain properties. Okay, so these things it has to satisfy. Okay, so a true IoT device, it has to be a low power device. It has to be a battery operated, and it has to be alive for a few years at least. You can't keep on changing batteries often, and it should give long range in terms of radio communication. Okay, that communication protocol will take care of it, and it has to be very reliable. It is some time critical thing. It has to be very reliable and secure, because the data going in and out, so no one should be able to uh, like sniff in and alter the data or get access to the data. And memory is very limited. Okay, processing power is constrained, and sensor all mem sensor, low power sensors. And finally it has to be a real-time system. Okay, just think of an factory monitoring, factory machine monitoring. So you have deployed an IoT solution, and you are deployed a vibration sensor, and it gives the vibration of the machine, and you transport it to the cloud. So every time, every second, you are streaming data to the server, and when something goes wrong, and all the analysis happens in the cloud, because on the edge you can write certain cases, you can write if else. Okay, you cannot write more than that. You can write if the range crosses, if the vibration is like more than 30 or 40, or temperature is more than 100, then you can take some actions. Okay, but it's only limited to that. Okay, so you cannot write complex functions. And also you cannot find complex pattern, like whether it is a good vibration. Okay, sometimes machines will vibrate, right? Whether it is a good vibration or some nut or bolt is got loosen up, or else it is having more load, so that the problem is. So you cannot do this pattern analysis and pattern recognition, right? So if you have done a machine learning is all about pattern recognition. So how you can do the pattern recognition on board and like on chip, okay, on the microcontroller, like tiny microcontroller, and Arduino or ARM, how you can do that. So we have certain microcontroller architectures, AVR, Atmel, Arduino, and ARM, other ST microcontroller stuffs, and we have microchip based stuffs. So all these things are quite popular, being used in the industry. And if you see the stack, so we have edge devices, the actual hardware and sensors deployed on the field, and we have connectivity, the communication protocol, radio, or the application level protocol taking care of stuffs. And on the third side, we have edge computing. Okay, so one thing what you can do is, let's say you have a factory, you can have your sensors deployed, and you can have a local server on the premise itself, so that can do some data transformation, filtering, and all, and then you can transport data to the cloud. Okay, so that is one thing, the edge or the fog computing has been enabled, that capability. So basically this machine will be some a decent computer, not a microcontroller, a decent computer that can do a whole lot of processing. Okay, that's there. But here we are trying to like do the inferencing on the edge device. Okay, so let's get back to the topic. Okay, introduction to on device ML. So why on device ML? So it enables low latency and close knit to interactions for devices. Okay, and network connectivity. It can operate without network connectivity. Okay, so let's take your face unlock system. Okay, so it happens on mobile, right? You are not getting help of internet or Google Cloud or Apple Cloud to do your face recognition. So it happens on board. Okay, so without network connectivity, you can enable a lot of smart capabilities. And third is privacy preserving. Okay, so there is one important area. So we have been seeing a lot of progress in AI and ML, but a lot of things have been happening as a proof of concept. Okay, so there is no, not no, but there is no much of actual use cases because data is too sensitive. Okay, so once data leaves your system, it might be a medical data, financial data, highly sensitive data, all these are, right? And even your smart band data, someone is having access to that and he can manipulate you easily. Okay, so privacy preserving, that's an important concern. But so if you do on device ML, so your data never leaves your mobile. Okay, so a lot of companies have been focusing on it. Your data never leaves your mobile. It works on board and everything is happening within the system. Okay, and it enables a lot of new generation products. Okay, well, right from your uh, like face like Snapchat filters or some makeup kits, like we have all those stuffs, and we have real time translate stuffs and all, and also your face unlock, your Snapchat filters or Instagram filters, everything works on board. Okay, and you have seen like the oldify concept and all, the recent trend, when you give a photo it morphs you as a old age, but those photos are sent to the servers. Okay, there's been a lot of concern on that. A lot of people told you to install the software, uninstall the software, because they are taking your images to the server. But on device ML can enable all these capabilities. So how you can do that? Okay, so how to optimize your models? Okay, so there are certain things how you can optimize models. You'll see them one by one. Okay, so the first thing is transform your ML models so that it can be more efficient to execute. Okay, as we have seen, it's millions of flops per second, and it has to be able to run that or execute that, and it should be able to run fast. Okay, with low memory low memory consumption, and also battery consumption. Okay, and faster inferencing. Okay, if you feed an image and if it takes 10 minutes or 10 seconds, 10 seconds like pretty huge, right? If you see the Snapchat filters, it works in real time, like 5-10 frames per second. Okay, and why do it? It has a lot of serious benefits, unlocks a lot of new use cases, and also you can do on device speech recognition, face unlock, object detection, and music recognition, and a lot more. Okay, and TensorFlow offers a suite of optimization toolkits. Okay, and if you see, we have TensorFlow Lite, we have MLKit, Android, Google Cloud, and Coral both. So everything's for different purpose. MLKit is very high level APIs. Some it is not that customizable, but few services are already there. You can use right away. And customizable models, you can develop them with TensorFlow Lite, or else you can deploy it on Google Cloud and you can make use of it. Okay, and hardware and Android. Lately, if you see all the Android phones and iPhones. In past 2 years, you have been seeing a new component being added, a neural engine. Okay, a kind of a fancy term. This neural engine will be responsible for doing all these inferencing and making things faster. Okay, so yeah, we'll come to that. But what is TensorFlow Lite? Like this TensorFlow Lite, it's a toolkit, part of TensorFlow, which enables to run all those models in the hardware. Okay, so TensorFlow Lite, like you can deploy your models, like production ready models. These are not just prototypes. It's very reliable and production ready models. You can deploy it on Android phones, Apple phones, Linux systems like Raspberry Pis and other tiny local edge systems, and also ARM based microcontrollers. Okay, and there have been a lot of devices actually running those things. More than 4 billion devices actually run that. Okay, TF Lite in production. And these are all some of the products, right from your Google keypad, Word, next word prediction, to YouTube, to hike sticker prediction, to Airbnb. Everything uses the TF Lite in it. Okay, so what TF Lite can do, it can do, AI is, we have seen a lot of progress like reinforcement learning, GANs and stuff and all, but it cannot do all those things. TF Lite can do very simple things, but much faster. Okay, the general things which been robust and reliable, text processing, cam scanner, okay, all those OCR stuffs, speech recognition, text to speech and speech to text and all, voice, Google Voice and all, and image we have a lot of things, detection to classification to segmentation, compression, super resolution, all sort of stuff, audio analysis and video synthesis, and finally content video generation and all. So if you see the TF Lite workflow, so the first thing would be train a model. Okay, train a TF model. And the second thing would be convert the model into TF Lite format. Okay, and third is deploy and run on edge device. Pretty simple, right? Okay, so the thing we'll be focusing on how to convert. Okay, what are all the types of conversion and how we can actually enable the edge ML using TensorFlow. Okay, so why I'm not why I'm focusing only on TensorFlow, because TensorFlow, so there are two deep learning frameworks that is quite popular. There have been a lot like Cafe Theano and all, but PyTorch and TF are quite popular. Okay, I like PyTorch. I use PyTorch most of the time, but PyTorch is more of flexible, and it's used for research purpose, like for building new things. TF, Google, they have been very clever. From initially, they're focusing more on the business use cases and deployment use cases. So they have all these system production ready so that we can easily do that. So that's why I'm focusing on TF. But again, PyTorch has all these capability, but in a much more complex way. Okay. So first thing, let's train a model. Okay. So we have all these model building stuff, sequential layers, convolution layers, and recurrent layers. You add it up, you train it, you do the fitting process, then you evaluate it, and finally you have a model. Okay. So what you can do with these model is you can save it. Okay, you can save it and ship it or transport it to another system and use it for deployment. Okay, so the second thing would be the conversion part. Okay, so while building all these models, so a model is nothing but an architecture and the learned weights. Okay, so architecture will have some memory. Okay, and also the weights will have some memory, because let's say 500 nodes, nodes here and 10 nodes here. Let's leave the dropout. Then 500 into 10, it's 5,000 connections. So if, let's say, if every connection, it's a value. Okay, if every value is of 64-bit float, 64-bit. Okay, then it is a 8 byte. Okay, then for 5,000 values, let's make it 10,000 for easy computation, like 10,000 into 8, so 80,000 bytes. So 80,000 bytes, if you take, it's 80k. Okay, so every values and every architecture occupies some memory. So if you have very big network, so the memory will keep increasing, because all these, to, in order to accommodate the architecture and also to have all those weights and values, you need the memory, right? So next you can store it. So all these values and the architecture are stored right away like a formula. And what you can do is you can optimize them. Okay, so using the TensorFlow Lite converter, so you can see it is a saved model, and you can use the tf.lite.tf lite converter. One shot, you just pass the model or the path to the model. So we have different model formats like pb and h5, so you can store it and you can do the conversion right away. Okay, so it's too simple, but I will tell you what happens behind the scene in the coming slides. And next you can deploy it. Okay, so deploy it, where you can deploy it on mobile phone. This is an iOS code to run a TF model. So iOS has its own SDK to run the like it's an interpreter. It can actually load and do the inferencing of TensorFlow models. Okay, so you can see there's an interpreter, it takes in some input, and finally it invokes and you get an output. Okay, so this is how things goes. And next is optimized for edge device. Okay, so we will not focus on the Android and iOS stuff. It's been okay, that's been quite popular these days. But let's come to the embedded device. Okay, so if we come to embedded device, those are very limited compute power, very limited memory, okay, and battery consumption, operated by battery, and app size. So if you see the modern chips will have like 32 KB of flash memory and few bits and bytes of RAMs, and also certain megahertz. Okay, so all these things run on megahertz, not gigahertz. Okay, and it's a one single chip. Okay, so how you can run models on these chip? Okay, either these devices or else these chip. Okay, so we can take advantage of four things. Okay, so how to run? Like first is leverage hardware accelerator. So I've told, right. So all these modern mobile phones have the neural engine stuff. So we can make use of these hardware accelerators. Okay. The second thing is we can use mobile optimized model architecture. Okay, so there are mobile optimized model architecture which can do inferencing much faster. So we will see what the architecture is. And third is apply quantization. So applying quantization and applying pruning is the quantization or the model conversion technique. Okay, so two important technique which converts the big model to the light model. We will see them one by one. Okay, so hardware accelerator. So the last 20 minutes I planned for demo. I'll quickly go through, finish the slide by 6:40. Okay, last 20 minutes we'll go for demo. Okay, so first thing is hardware accelerator. We have you can see the inferencing time, like floating point mobile net. It's a image classification model. Mobile net floating point operation takes 37 milliseconds, and quantized model, fixed point quantized model, take 13 milliseconds. And using GPU accelerators, OpenCL general interface, and using GPUs, it is 5 milliseconds. And again, quantized, and again using the edge TPU, everything takes like 2 millisecond. Like 2 millisecond, you can get a lot of frames per second, right? So it's about 18x faster than the normal inferencing. So Android has all these things. Android has GPU, Hexagon, DSPs, uh, neural network APIs. Okay, always have, and iOS has GPU and Core ML. So you can do this. Qualcomm and all chip manufacturer now lately adding all the stuff. We can invoke it and do. It's like Apple Neural Engine, Core ML to accelerate TF-Lite models, and A12 SoC and 14x speed up. It is actually providing. Okay. So how you can do that? Every language, if it is uh, uh, Android, it will have a Java or Kotlin uh, uh, code to invoke or else to make use of GPU. Like you can create an instance of, you can just hook into the GPU and you can load your model and you can do the inferencing. So that GPU will be allocated for your ML inferencing, and it will actually speed up the process. So that is one thing, right? And the second thing, if you see the optimized model architecture. So if you take image classification, okay, if you show something, it tells apple or banana, whatever it is. That's image classification. People who don't know that, okay. So we have two architecture, Inception and MobileNet. Both are from Google. Okay, Google Inception v3 and MobileNet. Both are from Google. But Inception, you can see it's a base model. It is very big one. Okay, it has a lot of parameters and inferencing time is too high. And MobileNet is a modified version, so they have made altered a certain architectural change so that it can do faster compute, right? So it is like see it is like 8-bit. So why all the numbers or chips are in like if it is 8-bit, 16-bit, or 32-bit, it is easier for the memory or RAM to load the values in the register and do the computation and write it back. Okay, so coming from electronics, like I'm just telling it to the chip level. Okay, so in the, down the line, how chip works is it basically runs zeros and ones, right? So in the top level, if you have a proper number, okay, so it can do the computation much faster and maximum utilization of hardware can taken care of. Okay, so there's no big difference. So if you do top 1% accuracy between Inception and MobileNet, it's nothing much. And 5%, top five accuracy, it's almost same 6%, and it's 15x faster. Okay, and it's in 10x smaller. So that is what the architectural wise advantages we are getting. Okay, you can see the same thing. And again, here the green is the mobile net stuffs. Okay, and the green is about 300 million, and you can see the top one, the NASnet or the ResNet, is 3000 million. Okay, the multiplication which is happening, you can see the performance is pretty similar, right? So 10x speed up in the architectural changes. So first thing, make use of the hardware. Second thing, choose the right architecture for your application. The third important thing is quantization. The quantization is where you are uh, you are compressing of the model happens. Okay, so what we do is basically we reduce the number of bits for model weights and activations. I told you, right? So the model is nothing but the architecture and the weights. So all the weights by default will have float 64 format. We can convert into integer 8. Okay, we can round it off. We can round it off to upper limit, or we can round it off to lower limit. And if you do that, still there is no if you do that, what will happen is, like, if you convert from float 64 to int 8, so there is 8x reduction in size. So 100 MB to 12 MB. Just think of like 100 MB. If you deploy, if you have a model and you wanted it to be in your Android app, and if your Android app is more than 200 MB, no one will download it, right? So if you make like your model alone is 100 MB, then just think of like how much size your app will be. So that if you minify it to 10 MB, 10x small, then 10 MB your code, 20 MB, 30 MB app published, right? So, and again, there is no big accuracy drop in this thing. Okay, so we can do a lot of, there are a lot of quantization technique. So one is post training quantization, where you just blindly convert all the float numbers to integer numbers, and also there is no that huge performance drop. You can see v1, v2 and ResNet. So there's only 1% or few percentage accuracy drop. Okay, and also there is also quantization aware training. Okay, so sometime what will happen is the accuracy might degrade, because all those matrix multiplication, like let's say your answer has to be 6, then 2.9 plus into 2.9 into 2.9. Okay, so just think of like instead of doing 3 into 3 9, we have round it off to the lower bound, like 2 into 2, then it can be go 4. Okay, so we will not do that anyway. If it's more than 0.5, we'll make it round to 3. But sometime it might be, if you have more numbers, more weights and values in your model, things will happen in a way like your performance might degrade. In that case, you can go for quantization aware training. So where during the training process itself, quantization will happen. Okay, the conversion of float to integer will happen, but still maintaining the same level of accuracy. Okay, so you can see there is no accuracy loss at all. So we have dynamic range quantization and integer quantization, direct conversion. Okay, but there is no need of data, small accuracy loss. Okay, but quantization, you need training data because it happens during the training process itself. But there is only a smaller accuracy loss, better than these two things. Okay, so again, default one, post-training dynamic range quantization. Again, post-training quantization, you can directly use tflight.converter, and you can use optimization property. You can mention it. Okay, tflight optimize default. So default is dynamic range quantization. We have a lot more. We will see that in code. So you can right away convert it. And the second thing in optimization in architecture level is pruning. So drop certain connection which will not be used. Okay, so if you see GPT-3, okay, the GPT-2 or GPT-3, all those language models, um, you have been heard of a company called Hugging Face. They have been doing NLP, like compressed language models for production use cases. Okay, so if you see, there is one rule that is general for everything: 80-20. Okay, so 20% of the thing responsible for 80% of the result, and 80% of the thing will be responsible for 20% of the result. So this pruning is two things. One is remove unnecessary things, and if there is also something a capability it is losing, so majority of like 20 to 30% of the connections and neurons will be responsible for the majority of the prediction and outcomes. Okay, so we can do the pruning, and we can round it off, or we can make all those weights zeros, and also we can chop off those connections, so that the multiplication or the computation will be saved. Okay, we don't have to do all those computation. So that's how we can also reduce the model size. Okay, so pruning you can done up to 50%. 50% is like chop off half of the connections. We will see that the benefits, like smaller models, sparse tensors can be compressed, and faster models, less operations to execute. You can see if you chop it off to 50%, okay, there is nothing big drop in accuracy. So once you cross 75% of pruning, you can see the drop in accuracy. But up to 50%, there is no much drop, because 99% of the use case will use those 20 to 30% of the connections that will be responsible for the output coming. Okay, also you can do a pruning You can use polynomial decay, and you can set up like how many percentage where to where and all, and you can do your pruning. But all these things being looks like pretty complex and very technical. In the demo, what we will see is we will use an easy ML platform which can do all these things right from the data acquisition to the training to the quantization to the pruning to the deployment in one shot. Okay, the end-to-end tiny ML pipeline. So that is what we'll be seeing in the demo. Okay, fine. So again, TF, they have recently added TF model maker. So this model maker, you don't have to do this coding process what you have shown. Okay, so just you can just invoke and write few lines that can do it for you. But this is not for the today's topic. It's mostly for mobile, for ML, ML for mobile phones. Okay, and so Android has all those plugins. If you want, you can go where here. Okay, so here, and you can check that it's available in beta version only. So ML mobile modeling, you can go there and you can check it, but still not yet released, right? But we will come on to the microcontroller part. Okay, so if you just give a recap why it is important, because edge capability, it can open up new use cases, and we have seen TF Lite workflow to optimize four things. Either you can do quantization and optimization pruning on the model level, and also you can take leverage of the model architecture and the device hardware, GPU or whatever it is. Okay. So you can see in the 2020 only, they have added a lot of all these models. You can see microcontroller support, GPU, DSP, and TPU delegation, and all sort of stuff's been recently added in the quarter 1 of 2020. Okay, now let's run the actual model. Okay, so again, coming to this, um, no operating system, tens of kbs of RAM and flash, CPU only, and access all around. And if you see how it works in the sense, see, once you save the TensorFlow model, so we have the TensorFlow Lite flat buffer format. So that is what the format after the conversion what we will get. Okay, and in the chip level, in the Android level, in the iOS level, and also in the microcontroller level, so we have all these interpreters. So these interpreters will be responsible for loading the model and do the inferencing. Okay, so let's see the process. TF model, saved model, light, and deploy. And during inferencing, how it works is it loads your model and pre-process the data, because you cannot feed data directly to the model, because the model will have certain formats, like in this resolution or else in this data format I'm expecting the data. You would need to do the pre-process and interpreter and use the resulting output. Okay, so that way you can do that. And what are all the availability right now, and still it is not that production ready. We have certain SDKs and code for TF Lite. So we have official Arduino library. Okay, and we have Spark Front Edge board, that was the first board proposed by Google, and we have ARM embed discovery board and stuff and all. So what you can do, you can do this. Okay, basically you can do onboard gesture recognition using accelerometer. It takes in all those XYZ values of the accelerometer, and it's just pure signal, raw signal. But from the raw signal, you can actually do the gesture recognition. It might be a punch, or it might be bicep curls, whatever it is, you can do that. And other applications, speech recognition, person detection using camera. Okay, for CCTV cameras, and gesture recognition using accelerometer, and predictive maintenance. We have all these stuff. So even if you take the Alexa or Stump devices, it has two types of models. One is the edge model. So edge model will be always active. Okay, so whenever you tell, hey Alexa, the edge model will be recognizing your voice and will be booting up or turning on the actual device. And then next the command you give it, it gets recorded and sent to the cloud. So things are like that. So simple yes no, or a lot of applications you can build upon, build like bird identification, bird sound identification, either someone is sounding or not, water drops. So whole lot of things you can do that. You can see still it can, it's a 20 kb model, still it can do millions of operations per second. Okay, 7 million ops per second. Okay, and person detection, you can have a simple tiny camera, battery operated. You can find whether an intruder is coming or not. You can do animal tracking in forest, because deploying a device in the forest itself pretty hard task. But when you wanted to classify, so there have been cameras deployed in the forest, but all those things are recorded and taken back to the department and then being analyzed. So what if you can do real-time tiger or cat, not cat, elephant is there. So you can do this personalized person detection. And gesture detection can be used in a lot of places. Even your smartwatch has a lot of these capabilities. And again, ARM and TF are working together to enable all these things. Okay, so now let's come to the code part. Okay, so we'll be using a platform called Edge Impulse, as I told you, right? So this TinyML as a working group, it has an end-to-end TinyML workflow. So this Edge Impulse platform actually implements the end-to-end TinyML workflow. Okay, and here, right from the data acquisition to the data transformation to the training to the inferencing, everything we can do it on platform itself, like super easy, right? So the board what we'll be using is this board, the STM discovery board, STM microcontrollers discovery board. So it has a lot of modules, like it has onboard BLE, Wi-Fi, NFC, and it has gyroscope, accelerometer, and magnetometer. It has audio mics. It has even mic. You can do voice recognition using this device. So it's a dev board. It's not a production ready board. It's a dev board. So now let's use accelerometers to do some gesture recognition. Okay, fine. So I'll move on to the browser. Okay. So one sec. I'll just open my screen. It's here. Okay. So you can right away go to Edge Impulse. You can search them, right? And you can get them. You can find them on the internet, right? So you can go to their pages. So now I have already logged in. So I have this page. Okay. So this is the dashboard. So and you can see one device connected. Okay. So this device, let's go to the website and see what all they has to offer. Control Shift T. Okay. So Edge Impulse, making things smarter. You can see crane operation, healthy, yes or no, and you can see animal activity tracking. Okay, all these things are tiny chips, which is actually doing the inferencing, like heart rate variability. So right from the data set acquiring to the impulse design to testing and deployment. So it has like it is the actual the code is beginning the scene, but it is one easy interface where anyone can build TF-Lite model. Okay, so TF-Lite model, you should know ML, you should know TensorFlow, you should be very good at TensorFlow. Then you can only you can move on to the this optimization part and all. But this thing will take care of all those stuffs, right? I also have a code to show it to you how things happens as a bare code. Okay, right. So first thing first, what we will do is we will go to the official manual page. We will follow the type guide itself. Okay, so I'll just zoom in a little bit. So what they have told you, what they're telling, like take the board and install the npm client. I've already installed it. Okay, in my thing, I've already installed things. Okay, the npm package for connecting your device to the cloud. Okay, and next connect your board, and we have to start the daemon so that we can give your wi-fi credentials to enable the onboard wi-fi module. And also you can give your credentials for the cloud. Okay, so once you give all these credentials to the cloud, your device will be connected to your server. Okay, so you can see device, it's still connected. Okay, I'll show it to you. And what else? So and again, that's enough. Only you have to connect your device, but before that, what you do is you have to download their binary. So their binary is what, so you can download the latest firmware, so it will get a bin file. Okay, so this bin file. But before that, I will turn on my camera to show you the actual device. Okay, I think my camera is visible. Yes. So this is the device I have with me, this device. Okay, so I've connected through my USB cable, micro USB cable to the computer. Okay, so once you connect this, what will happen is you will get this. Okay, so unlike other chips, you would be flashing it. So but this as a file system, what you can do is you can easily drag and drop the file here. Okay, drag and drop the file here to install the model. Okay, so here you have the downloaded binary. Okay, so you can take the downloaded binary and you can drag and drop to the system so that it gets installed. Okay, it's taking some time because Zoom is eating up a lot of RAM. So yeah, let's down. Okay, let's drag it and paste it here. Okay, so it will be installed. The actual the binary code what we have downloaded will be flashed to the device. Okay, so connect your device. Okay, and install the client and run this After running this, you have to before running this, you have to install this. Only then the edge impulse code will be on the board on the cloud as well. Okay, so now we have our binaries installed in the device. Now we can run this. Okay, but it will take some step. I will skip those. You can give your Wi-Fi name and Wi-Fi ID and password, and you can also give your credentials. So once you give this, your device will be live here. Okay, just you can reload it and see where device will be up and live here. You can see the mic here. Okay, green dot. So let's go and do some data acquisition. So data acquisition is where the uh, okay the collection of data happens. Okay, so remember we are doing gesture recognition. We are doing four things. Okay, so we will do four gestures. One is wave. So if you wave it, it is able to find it. And up down. Okay, up down motion. And snake. Okay, some snaky movement. And idle. So we are collecting all the accelerometer data for these four operations. Okay, so I've already loaded few data, but how you can collect data is your device is already shown up here, and you can give up some labels up down, and you can give the sample length, data acquisition, and you can use built-in accelerometer or microphone, and you can go for start sampling. So once you do start sampling, it will tell you to start. Okay, then you can do the up down motion. So during up down motion, all the accelerometer is being recorded, and the data is collected by the edge impulse server. You can see it is uploading. Once it is uploaded. Okay, so here the data is the your raw sensor data, and this is your label. So remember here we have four labels: up, down, wave, snake, and idle. You can see right now collected data. It is in this manner. So X, Y, and Z values for the accelerometer. You can see there is for up down there is more wave in the more change in the Z axis, because that is what is continuously moving. On the X and Y axis there is no much movement. So by visually itself we can understand what motion I have done. Okay. So I'll delete this because data has to be proper. ML is 90% data and 10% modeling. If your data is right, your model can be right. So I'll delete the already newly calculated data. This is predefined data, which is available in the Edge Impulse platform itself. You have wave and other up, down, and all. You can inspect them and see what it is, and also you can add this data, right? So now we have this raw data for 10 seconds. You can see 0 to 10 seconds. For every second, it's 62 samples, like 62 hertz, 60 samples per second. That's frequency. Okay. So totally we have for 10 seconds, 60 into 10, 600 sample points for the 1 10-second thing. So now we need to filter those data. So these data we directly can't feed into the model. Either we can use RNN for sequential process, but here we will use CNN. Okay. So CNN or traditional neural network. Okay. Normal feed forward neural network, but you have to do the feature engineering. So feature engineering also you can do it with edge impulse. Okay. So here what you can do is you can uh, chunk your data into pieces. So here the window size I'm giving is 200 milliseconds. I'm zooming a little bit. 200 seconds. So 2000 milliseconds. So it is 5 chunks for 1 second. So you will get 5 data. So up down in 10 seconds, you can basically do approximately 5 up downs. So that is why this window. And spectral features, you can add spectral analysis for frequency and power character extraction. This is basically a fast Fourier transform where you can apply the Fourier transform on the raw signal to convert them. Okay, so that we will come to that part. And also you can do the flattening, image processing, converting the color and audio frequency, audio data extraction and all. So here we are adding the spectral analysis block. And here we are adding a neural network block and also anomaly detection block. So either you can also add blocks. Here we have neural network block, anomaly detection block, and transfer learning block. So this neural network block will be responsible for classifying these four classes. Okay. So idle, snake, up, down, and wave. So why do we need this anomaly detection? So if you do some other motion like rotate or some shaking at fast speed, so there you would get some new data. Shouldn't be misclassified. So in that case, we can train a k-means anomaly detection model so that that different pattern will be classified as an anomaly. Okay. So we are adding all these blocks. And finally, you get the output. So output will be of 5 classes: idle, snake, up, down, wave, or anomaly. Okay, now we can save impulse. You can add blocks. So we will come to everything one by one. So next is spectral features. So this spectral feature is actually where the feature engineering happens. So here you can select the wave. So let's choose up down. So up down, you can see it is 5 windows in 10 seconds. Okay, and you can see you can also do the parameters. So scaling one and filter type is low pass filter to reduce the noise and distortions. Okay, it smoothens the wave, and also cutoff frequency we are adding and doing the fast Fourier transform. So Fourier transform will be responsible for converting the time domain data to frequency domain and vice versa. You can do that FFT and other inverse FFT. Okay. So here you can see this particular wave is smooth and you can get it here. And this is after filtering and after the FFT frequency domain transformation. You can see here it is a frequency domain wave. You can see there is more blue component because more blue component is more Z component, the Z axis component. And also you can see the spectral power. There is more spectral power on that area. And so this is raw features. So this is raw features. If you copy it and paste it somewhere in the notepad. Okay, so it's a very lengthy one. So it has, as we have seen, like that many samples for the data for every second. But after the feature transformation, so it only takes in account of the frequency domain and spectral domain. So it actually gives us these values. So these are much more lesser value, which still has all the pattern data in it. Okay, but it is and feature engineer data. Okay, this is where feature engineering comes in. So after so this is the process how things goes. Like raw data is applied certain filters and it's converted, and now we can do generate features. So once you run generate features, so for all your 4 into 10 minutes, 10 seconds into different samples, it's totally 8 minutes 50 seconds of data, and you can generate the feature. Okay, so once you create the job, I have already generated the feature, so that's why it right away gave us the answer. But it will take a few minutes to generate the feature, like convert all the data, collected data to the newly converted format, like from these data to this data. Okay, so after doing that, here you can see you get all these values like accelerometer X, RMS, peak, frequency, height, and peak to frequency, height, and all, and spectral power for this thing, and also for y-axis and z-axis, you get all these. Basically, 33 features, I think 33 or 34 features. And if you choose the x-axis, y-axis, and z-axis RMS value alone, for ideal snake up, down, and wave, you can see clear difference. So ideally, there is no movement in all three axes. In for snake, in one particular axis we are getting like in x-axis, because x-axis is going in this direction, and for up down there is in y-axis. For z-axis, for wave it's a different axis like z-axis. You can clearly separate. You can use simple support vector machine or decision tree or logistic regression to draw the decision boundary. Yeah, so likewise you can compare all these things. So now what we'll do is we'll use all these data to train a neural network model. So let's go to the neural network classifier. Okay, so this neural network classifier will have a classifier block. So here you have I'll copy this, and it's not that visible, I think. I'll open it in the VS Code. Okay, I think it will take more time, but anyway I will just explain through the code meanwhile. So we are importing TensorFlow. We are taking in sequential, dense, dropout, convolution, 1D, 2D, all those stuff. Okay, and finally we use it to like I'll come to the Python code. Okay, so model.py, highlighting. Come on, VS Code. Yeah, got it. So now you can build a model. You can add some layers, horizontal, vertical layers. You can do whatever the architecture you want, and you do the Adam optimizer, and you set the batch processing, and you compile and you train the model. So this model gets trained on the data what we have collected. So basically the input is the 33, whatever we feed in. You can see the input length here. The input length is the actual size of this value. So I think it's 33, I think. So 33 values we have in. Okay, so we pass it. So what you can do, you can write any code. You can add your own RNN layers, convolution layers, whatever it is, and you can do the start training process. So remember here we have given epochs as 100 epochs. That way it gives good accuracy. So run it. So it will create a job. Okay, it will create a job in the back end, and it will use the data, and it will run the neural network classifier. Okay, it will train the model. You can see the loss and accuracy, validation accuracy, and training accuracy. It's been improving. So training accuracy 97%, validation accuracy 98%, pretty fast because our data is clean. You don't have to do complex architecture. And once it is trained, I have already trained it, so you will get a confusion matrix. And to find the misclassification, like diagonal values are maximum, so precision, recall, F1 score, everything is maximum to 1, and accuracy is 100%. Okay, and there's no loss and 4 classes. So and again, if you see, it will also give you two models. One is unoptimized model float 32 and optimized model quantized model int 8, and you can see the difference. So it is 17 kb of 17.4k of ROM usage, and this is 15 of ROM usage. Not big difference because it's a simple task, but it will be more most of the time. Okay, so the difference will be recognizable. So so as things goes on, you will we will get better model accuracy. We have to wait till 100. Okay, so next thing, once the model is get trained, what we can do is, meanwhile I'll make a ready one thing. I'll open a code so that I can quickly show you. The model is getting trained. Anyway, we'll go to the code. Okay, close one. Fine. Will not be more than 5 minutes. We'll finish on time. Okay, so yeah, so once it is 100 epochs passed, so finished training, you can see model is converting to TF Lite model. So the steps, the code what I have shown in the slide, that process will goes on, and also that int 8 model you will get it. Okay, basically it will be 64, but it will convert into 32 and int 8, both the format. And now you can perform like do the things and all, like testing, validation and all. So, and also we have to train our anomaly detection model. So here we'll use cluster count 32. We have 32 features. We will choose only these three, and we will do the start training. Okay. The k-means model. K-means is clustering based model. It takes an head and finds the neighboring one and takes the mean variance and to create the group. And now you can see for any data, like you can see every data falls within the group. If the data falls outside of the group, then it is an anomaly data. So you can choose any testing data. So this is the testing data. You can see if it is classified, you can see it is on outside. Okay, so so the normal distance for the k-means clustering, all the details you will get it here. Okay, fine. So now we have trained our model, neural network model for classification and anomaly for real-time anomaly detection. And now let's go to the live classification. So that is where live classification happens. So live classifications. So now everything is on the cloud. Our model is ready. Everything is in green color. Now let's do some real testing. Okay. So I'm using the device this. I'm just calculating for 5 seconds built-in accelerometer, and let's do 6 seconds because we have chopped into two, right? And frequency is this. So what we do is let's do the start sampling, and waiting to start, and things started. Okay, so I'll do up down. Okay, so this data will be uploaded to the cloud. Okay, and we can find what thing it is, like what action or what gesture I have done. Okay, so this is the new testing data. We will do the classification for it, but here the classification is happening in the cloud. It's not yet on board. Okay, so you can see it is testing data. You can see the pattern, and it is 41% up down. Okay, and also 1% are uncertain and 9% anomaly detection. Okay, so because the gesture has to be a proper thing, I don't know how the train data is taken, either this side or this side. It's slight change in the board handling also will give you the different error. And you can see the anomaly detection and all the details here. So if some data is misclassified, you can add the misclassified data to the training data, and also you can use that to retrain the model as well. Okay. So now the cool part is, let's get to the deployment. So now if you go to deployment, so the deployment is where Edge Impulse have done a beautiful thing. You can get a C++ library, you can get an Arduino library, you click on it and you download it, you get an Arduino library. And you can also get WebAssembly. You can load it with Rust on your browser, and you can do on browser ML. Okay. And it also has binary for all these three devices: ST discovery device, Arduino Nano device, and ETA compute device. Now let's choose this. So because we need, and we don't need to analyze optimization at all, let's build it. So once it is built, you will get the binary file that you can drag and drop to a device and do your live inferencing. And also you can also download the Arduino code. That is what I have already downloaded and kept it here. So this Arduino code will have a BLE sensor code, simple examples. So load all those stuffs and do some, write a while loop and gather the data from here and do the inferencing. Okay, so this is where inferencing everything happens. Okay, run classifier, this is where run classifier. So where does this run classifier comes from? It comes from, we have already imported. So we have imported with these STM inference and Arduino LSTM. So all these, the code will be available here. Okay, so, and also the model parameters you will have here. This is for clustering. So again, this is nothing but a neural network model with the architecture and also with the data. You can get the metadata and all, and you can get the DSP block, and you can get the anomaly parameters. Okay, basic multiplication, matrix multiplication, same thing happening here. So you can compile it, you can add your own logic it, and again flash it back to the Arduino device. But one easy thing, we have got the file here. Okay, now let's go and install it. Where is it? This is one window. Okay, 2 more minutes. Yeah, let's take our device and let's drag and drop this device to the our STM board. So once it is done, your entire neural network model goes into the board, and the board can will be run. Okay, once it is run, once it is activated, what will happen is it will gather the data from the sensor, it will do the Fourier transform data pre-processing. Okay, and it will pass the data to the neural network model and KNN model to do the inferencing, everything on board real time. Okay, so for that, what you have to do is you have to invoke the device. So that is where this things comes in. Okay, uh, and again this one, so you have to give edge impulse run. So remember, our board is already connected, right? I'll open the terminal and I will run the code. Okay, so once you run it, um, okay, you can see the classification is happening. So now the board is idle. You can see 99% it is idle. Okay, now let's I will take the board. Okay, and I'll do some up down. You can see the percentage score for up down will be increased. Okay, so you can see the up down is increased there. So yeah, this one, okay, up down is being increased. Now let's do the wave. Okay, so wave is wave is this waving. Okay, so if I do wave, you can see wave, you get 99%. Okay, and also if I do snake, I don't know what motion is. If I keep it idle, and again idle, you can see snake again 99 here, and idle will get idle 100%. So you can see classification 1 millisecond, anomaly 1 millisecond, DSP 14 millisecond, and inferencing is 2 seconds. Like the total inferencing can alone take 2 seconds. Okay, that is good enough. So if you have any machine is going to file, it is giving some anomaly vibration. Okay, it can do some real analysis, like it is a sign of failure or sign of breakdown. You can immediately stop the machine. Okay, right from getting the analyzed data on board itself, instead of transporting all the data to the cloud and processing it and activating, sending the command back to the device and turn off the device. So this, the entire loop is further closed. Okay, everything happened on edge. Okay, so that's it about the demo. I think you liked it, and that's all. Edge Impulse is free to use, and I'm one of the beta developers for Edge Impulse back last year. Now they have made it open for all the developers. Anyone can go and sign up. You need a Arduino BLE32 board, okay, or else STM discrete board. This cost around 4,000. This cost around 2,000. This I don't know. It's not available in India, I think. These two things you can buy from Element 14, and you can do your you can build your cool projects, whatever it is. Okay, there are few examples also available, like recognizing sound and other stuff and all. And that's all. Thank you so much. I think any questions you can drop it in the chat box. And with that, I have one more slide to show. One second, and this is this slide. Thank you so much. Thanks, Geeknight, for the opportunity. So Geeknight is what where I've introduced to the communities back in 2017 and 18. This was the only community in Coimbatore been introduced and helped me a lot in picking up technology skills and all. But later, GDG, Facebook Circle, TFUG, Cova AI, all these things came into place. So we are on Meetup and other platforms. If you need AI only content, you can reach out to our Meetup pages. We have monthly events like Geeknight. And Geeknight, of course, as every time, it's awesome. Happy to be part of it. And thank you so much. Thank you. And you can reach out to me on my mobile, email, and blog. Connect me on LinkedIn. If you wish. I'm more into education. Happy to contribute and collaborate and involve in communities as well. Yeah, thank you. Thank you so much. Srikesh?
Yeah, I think Nandita is here.
Thank you so much for being here today, Navneet. It was a pleasure hosting you at Geeknight Coimbatore.
Okay, thank you, ma'am.
And as for our audience, thank you so much for being here today. And in case you're willing to be a speaker and present your talk at Geeknight, please use the link. It's a link to the form, and you can register your talk using the form. And if you have feedback for us, please provide it using the form. Thank you, and that's all for today.
Yeah. Thank you, Navneet. Thank you,
Yeah,
Nandita.
thank you, Shrikesh. Thank you, Nandita. See you. Bye bye.
Thank you all who joined this meeting. Thank you.
Thank you.
Bye.